Okay, so what we're doing in this video is we're going to look at a couple of examples graphing polar equations, and we're going to start with graphing some roses. Now, what I have here is the basic equation for the basic setup, general setup for roses. And so we have the two types that we would expect to see if we are going to graph a rose, and that is r equals a sine n theta and r equals a cosine n theta. And pretty much they're the same curves, just rotated. Now, another thing too that we can pick up on and might help us graph later is the number of petals that the rose will have. And the number of petals that a rose can have can be determined by looking at the argument of the function. And if n happens to be even, or say odd, then we're going to have exactly n petals. However, if n is even, then we're going to have 2 times n petals, right? So my first example that we're going to look at here is r equals 3 sine 2 theta. Now in this case, we have that n is equal to, so here's n, right? And n is, of course, even, right? So here we see that n, in this case, is even. So what we expect is that there to be 2 times n, in case 2 times 2. So we should expect 4 petals. So it's going to be a 4-petal rose. All right. Okay. Now what I like to do is to help me graph r equals 3 sine 2 theta. I like to use the graph of y equals 3 sine 2x. And the reason why I do this is just a quick and easy way to observe how r is changing as the angle increases. So in this case, the relationship here is that for my equation, my rectangular equation, y equals 3 sine 2x, x is the same as theta in the polar, and y is the same as r. So as x increases, that's like theta increasing. And as y increases in, as y increases and decreases here on this curve of y equals 3 sine 2x, that's how r is increasing and decreasing. Okay, so now what we're going to do is let's sketch the polar graph for this. And so let me put in the polar axis, polar coordinate system. Okay, so here's my polar coordinate system. So here we have the polar axis, and then this point right here in the middle, this is what we call the pole. And I have these 3 circles. These 3 circles represent r. Okay, and since the biggest that r ever gets is 3, I have a circle with radius 3 as the biggest circle. All right, now, so let's plot some points. So we see here that when theta is 0, right now I'm focusing on the rectangular graph. When theta is 0, my r is equal to 0. So we start right here at 0, 0. Now, the next thing I want to consider is what's happening as theta goes from 0 to pi over 4. So I'm looking at this piece right here. Okay, so as we go from here to here. So what's happening to r as we go from 0 to pi over 4? Well, as theta goes from 0 to pi over 4, r increases out to 3. So then what I do is let's see, if I sketch in, that would be pi over 2, right? And so pi over 4 would split this right in half like this. And I know that at pi over 4, the r is equal to 3. Okay. So r goes from 0 to 3. Okay, so it's going to increase out to 3. So we get something like that. Okay. Now, that would be my first portion of the curve, so I label that with a 1, so this would be 1 here. Okay, so now let's look at my second piece. My second piece, I'm going to look at what happens as the angle goes from pi over 4 to pi over 2. Well, as we go from pi over 4 to pi over 2, r goes from 3 to 0. So from this point here that we have, we're going to go from 3, and as theta goes from here to here, r goes from 3 to 0. So as I get closer to the line pi over 2, r is going to go to 0. Just like that. Okay. So next I want to see, well, what happens as r goes from pi over 2 to 3 pi over 4. So we're looking at this piece right here. Okay, that's my third piece. So from here to here, here to here. Well, the r's are negative. So what happens when the r's are negative? So we're looking at, so we said from okay, so let's draw in 3 pi over 4 first. So here's 3 pi over 4. Okay. And we're looking at what happens as theta goes from pi over 2 to 3 pi over 4. Well, all of these r's are negative, right? So we see they're below the x-axis here in terms of y, x and y. So what I do is I draw the extension of 3 pi over 4. So that would be this line here. So this whole entire line is 3 pi over 4. And what ends up happening is that all of this stuff here gets sent to this quadrant here, right? Now at 3 pi over 4, right, let's mark that out. So at 3 pi over 4, the value is negative 3. Now, if it were positive 3, it would be here. But since it's negative 3, now it's going to be over here. And since all of my r's are being transferred into this quadrant, or this piece, right, into this section, and they're supposed to increase from 0 to 3, then that means that, so then our curve is going to do this. It's going to go from 0, which is the pole, out to the point 3 over here. Okay, so that's 3. All right, now, what about from, let's see, 3 pi over 4 to pi? All right, so that's going to be our fourth piece right here. Now, 3 pi over 4 to pi, well, that's going to be everything from here to here. So everything in this portion, right, and in this section here. Well, once again, those r's are still negative. So all of those that are in this section get sent over here to this section. And everything in this section is going to go from 3 back to the pole. So we're going to start from here, and then we need to go back to the pole because this goes from 3 back to 0. So from here back to here. Okay, and that's going to be 4. All right. So now we need to look at what's happening from pi to 5 pi over 4. Okay, so it'll be in this section right here. Now the good news is that all of those r's are positive, right? So we're looking at so this portion of the curve now, right? So this would be 5, right? So we're going from here to here. And as theta goes from pi to 5 pi over 4, r goes from 0 out to 3 on 5 pi over 4. So here is 3. And we're going to start from the pole, and then we're going to increase out to 3. So from here to here, okay? And then from 5 pi over 4 to 3 pi over 2, which is this portion here, r is going to go from 3, from 5 pi over 4, 3, to 3 pi over 2, 0, right? And so we're going to go back to the pole again. like that. Okay, and so 7 is going to be what happens as we go from 3 pi over 2 to 7 pi over 4. So 3 pi over 2 is this portion. Once again, all those r's are negative, so all of these pieces, all the r's that are in this piece get sent over to this section over here. And what happens to those? Well, those go from the pole out to 3, right? So here's 7 pi over 4. 7 pi over 4 negative 3 is going to be this point. And what happens is that r increases from the pole out to that point. Okay, oops, that's kind of messed up. Okay, and then 8 is going to be this portion here. And what happens? Well, that means that from 7 pi over 4 to 2 pi, all of these get sent over into this piece over here, to this section. And what happens? Well, we go from 3 back to 0. So we end up with that. So this was 7, and this was 8. Okay. Okay, so now let's look at this example. So we have r equals 2 cosine 3 theta. Now here, here's n, right? So now we know n is 3, and okay, so this is odd, right? And we said before that if n was odd, then that meant we had exactly that many petals. And so here we expect to be 3 petal rows. Okay. And what we can do is we can use the graph of y equals 2 cosine 3x. Okay, so here's the graph of y equals 2 cosine 3x. And now let's draw in our polar axis. Okay, so here's my polar axis. Alright, so let's see. Let's get started. So we only expect 3 petals. Okay, so here we go. So my first rate that I'm going to draw in here is pi over 6. So let's say this right here is pi over 6. Now, according to my curve, well, first of all, when theta is equal to 0, we see that r is equal to 2, right? So we're up here at the top. And so when theta is equal to 0, r equals 2. So we're going to start right here. Okay. Now, what this says is that as theta goes from 0 to pi over 6, r actually goes to 0. So r decreases to 0. So we start here at 2, and then as we get close to this line pi over 6, r is going to go from 2 to 0, just like that. Okay, so that would be 1. All right, that would be my first piece. Okay, now what about my next piece? Well, we're going to go from pi over 6 to pi over 3. So pi over 3, let's say here's pi over 2, right? So pi over 3 is going to be right here probably. And what this says is that now all the r's are negative, so now what I have to do is let me extend this line, let me extend these two lines. So I need an extension of both the lines, pi over 3 and pi over 6. So let's extend pi over 6. Here's pi over 6, the extension. And here's pi over 3, the extension. And so all the angles that would be here are now in here, right? And so what this says is that on pi over 3, when I get to pi over 3, I need to be at negative 2. So negative 2 for pi over 3 would be right here. But all of these angles start at the pole, and they increase out to that negative 2. So from here, they need to stay in this section. You go from here out to here like that. Okay. All right. Okay, so that would be 2. Right, that's my second. Oops, that's my second portion here. Now 3 is going to be this portion as we go from pi over 2 to pi over 2. And once again, those are still negative. So all of these here get sent to this section here, and then we need to go from negative 2 back to 0. So from negative 2, which is right here, back to the pole. Right, so we go back here, and that would be 3. All right. Okay. All right. So next, I want to go now. We're here. Okay, so 4. And we're looking at pi over 2 to 2 pi over 3. These are all positive, so now I stay here. So here's, let's say this is 2 pi over 3. Okay. Now I changed the color a little bit here, so I wanted to stand out a little bit more. All right, so now what we're looking at is, what did we say, 4, which was 2 pi over 3, no, pi over 2 to 2 pi over 3, which is this piece right here. Now these pieces are positive, and we go from 0 out to 2 again. So at 2 pi over 3, we're at 2, and we increase from the pole out to that. Okay, so we get that. Okay, so that would be 4. All right. And then what happens from 2 pi over 3 to 5 pi over 6? Well, here's 5 pi over 6, so in between here and here, r goes from 2 now back to 0. So from here back to the pole. Okay, so that's going to be 5. Okay, and now we're back to the negative r's. And so from 5 pi over 6 to pi, well, that's going to be here and here. All of those, if I looked at the extension really quick, so okay, so there's the extension, and all the angles that would be in here, or all the r's that are in here, since they're all negative between 5 pi over 6 and pi, they get sent over here. And what do? Well, they go from 0 to -2, and so that would be from here out to here. Okay, and that would be let's see, I didn't label these. That'd be 6, I guess. So that would be 6.